Genetic engineering. You may be asking yourself a variety of questions about genetic engineering, such as how does it work? Is it practical? Well, to answer all these questions, we need to first look at what is genetic engineering. Genetic engineering is the modification of the characteristics or traits of an organism by manipulating its genetic material. To put it simply, genetic engineering is when you change the DNA or the biological code of a living thing, alter it in some way. Think of DNA like a recipe. Let's say you decide you want to bake chocolate chip cookies. The first thing you do is find the recipe. After gathering up the ingredients, you follow the recipe and end up with a final result of chocolate chip cookies. In terms of DNA, the cell of an organism that contains DNA reads it and follows its instructions, like a recipe, and ends up with protein. The DNA is the recipe and the protein are the cookies. This is important to understand because proteins don't cause an organism's traits or characteristics to appear. For example, a goldfish has a protein that gives it a gold color. Genetic engineering is when you modify the DNA that then changes the protein which alters the trait. So, if you alter the DNA that makes the protein for a goldfish to be gold into DNA that codes for a blue protein, then the goldfish will be blue, even though it's still a goldfish. The functioning and health of the genetically engineered goldfish will be the same, it just now produces a protein that makes its color blue. Now that we've explained what genetic engineering is and how it works, let's look at a real practical example that aids millions of lives every single day. Diabetes. It's an autoimmune disorder in which a person cannot properly create insulin because their own cells have been attacked by their own immune system. The immune system is primarily made up of white blood cells. These white blood cells attack insulin producing cells, destroying them. Without these cells, these people don't have insulin to allow them to take in energy, and they can end up starving themselves to death, even if they have been eating. Before the use of genetic engineering in laboratories, people had to use the insulin extracted from other animals, which wasn't very good for the people taking it or the animals at stake. With the use of genetic engineering, however, bacteria are genetically modified to produce human insulin. By altering the genes of the bacteria, we were able to place the human gene for insulin into the bacteria. The bacteria still function normally, except now they produce human insulin that we can gather and give to people with diabetes and help their lives tremendously. Another example lies in something you can find in your own backyard during the summer, the mosquito. Viruses such as the Zika virus have been hitchhiking on these insects for centuries. However, with new technology, mosquitoes have been genetically engineered to produce antibodies, which are a type of protein that attack viruses against Zika. With this new gene, the mosquito's health is not affected, and they now carry a gene that causes them will no longer carry Zika, which could save thousands of lives from this disease. This is only one use of many when it comes to genetic engineering, and with countless other aspects of genetic engineering to explore, the possibilities for great uses and discoveries are endless.